All right, so here's some tricks for comparing fractions. These can also be used for comparing mixed numbers because, as you know, when you compare fractions and mixed numbers, that's basically the same thing. The only thing is we're just adding a whole number. All right, so first shortcut that I have for you is if you're comparing fractions or mixed number, if all of the fractions have the same numerator, then the fraction that has the smallest number for its denominator is going to be the largest fraction. So for example, with all of these that I've got down here, let's say I want to put these in order from greatest to least. We'll see right here, 4 is the smallest number, so 3/4 is going to be the largest fraction, and that makes sense because I only need 4 pieces to make a whole, and I've got 3 of them. So that's pretty large. That's a large portion right there. So that takes care of this guy. And then of the ones left, 3/5 is going to be larger because, again, I have 5 pieces to make a whole, and I've got 3 of those, so that's more than half. And then, of course, 3/7 comes in. Well, 3/7 is more than 3/8 because there's 7 pieces instead of 8, and I've got 3 of them. So those pieces would have to be larger than 8 pieces. If you think about cutting your pizza up into 7 slices rather than 8 slices, the 7 slices is definitely larger. So this helps us put them in order. So if all the numerators are the same, this can help us out. The one with the larger denominator is going to be the smallest, and one with the smallest denominator is going to be the largest. And that makes sense if you think of fractions as pieces of a whole. Okay, so next trick. If you're comparing to fractions or mixed numbers, see, these are mixed numbers. Again, we'll see with mixed numbers, all I'm doing is the 18s don't make a difference in this case. They're just all whole numbers. So now I'm basically down to comparing fractions. We're going to compare them to 1/2. Now, 1/2, as we have talked about, has equivalent fractions. So we could get 1/2, and if we multiply by 2/2, we get 2/4. If we multiply it by 3/3, we get 3/6, and then 4/8, and then 5/10. And if you notice, every single one of these, and we talked about this in class, the numerator is exactly 1/2 of the denominator. So you can use that to help you kind of compare these. All right, so here's how we would use that on here. Well, I know that 1/2 of 5 is 2.5, so 3 is bigger than that. So this one is bigger than 1/2. So this is larger than 1/2. On this one, 1/2 of 12 is 6. So 5/12 is going to be smaller than 1/2. 1/2 of 13 is 6.5. So 7/13 is going to be larger than 1/2. So you might say, well, how does this help me? Well, here's how it helps you. I know that let's say I'm going from least to greatest. I know that 18 and 5/12 has to be the smallest one because it's the only one smaller than 1/2. That's it. Okay, so then I'm basically down to just having to compare 3/5 and 7/13. Now I could do it in this way. If 5 pieces and I've got 3 of them, so that only leaves 2 left. This one has 13 pieces and I've got 7 of them. I can tell that 3/5 is going to be larger in this case. Now, if you can't look at it and see it kind of like I can, the other thing that you could do is you could take 3/5 and you could take 7/13. You could find your common denominator by cross multiplying. So here we go. If I needed to compare these this way. So 5 times 7 is 35. 3 times 13 is 39. And 5 times 13 is 65. So if I did find my common denominator, which I did in this case right here, that tells me that 3/5 is the larger fraction. So if I was putting these in order from least to greatest, it would be 18 and 7/13 would come next, and then the largest is 18 and 3/5. But see, I got it down to where I just had to compare two of the fractions rather than comparing all three. So sometimes you can use this compare to 1/2 to kind of narrow things down. Okay, so now then, how would this help us out in a problem like this? Let's say I've got these mixed numbers and I'm putting them in order from least to greatest. Again, these are mixed numbers, and since all the 5s are the same, I'm down to comparing fractions. Now I'm just going to show you just a hypothetical. What if I put on here at the end like 4 and, let me get a big fraction, 15/16. That's pretty big. That's almost another 1 right there, because you have 16 pieces to make a whole and I got 15 of them. Well, no matter what, no matter how big this fraction is, 4 is still smaller than 5. So 4 and 15/16 would be the smallest one in this case, because the whole numbers kind of cancel each other out right there. So that's one of the things you can look at. All right, so let's go back to our original problem here and let's work it out. Okay, so working it out this way. Well, if I'm just looking at none of them have the same numerator except for 1/2 and 1/4. Well, I can tell that 1/2 is going to definitely be larger than 1/4 because 2 is the smaller denominator. Now that if I compare them to half of 8 would be 4, so 3/8 is smaller than half. Got to get it off my eraser there. It's smaller than half. 1/4 is definitely smaller than half. 2/3, that's going to be larger than 1/2 because half of 3 is 1/2. And this one is 1/2. So this one already is 1/2. Well, I've got a little bit of information here that's going to help me. So only one that's larger than 1/2 is 5 2/3. It's got to be the largest one, and I just put it in the wrong place there. So that wasn't great. All right. So 5 2/3. Let me get a larger erasing diameter here. So 5 2/3 is definitely going to be the largest. So I'll put 5 2/3 out here. So that kind of gets rid of 5 2/3. Okay. So I know that the next one has to be 5 1/2 because it is 1/2. The other two are smaller than 1/2. So then 5 1/2 has to come right here. And then I'm going to compare between 5 1/4 and 5 3/8. So this one I could either cross multiply, or I could just say, okay, well, I know that 5 1/4, if I multiply times 2/2, I would get 5 2/8. So 1/4 is smaller than 3/8. So then it would be 5 3/8. And then 5 1/4 out here, which remember we said 1/4 had to be smaller than 1/2 because of the denominator, the same numerators but different denominators there. So that helps put this one in order. So basically I just only wound up having to compare two fractions there. It was pretty easy just looking and comparing them to 1/2. All right, I hope this gives you a little bit more information that you can work with, and it makes it easier for you to compare fractions.